First, you need to go where it is there, induction, deduction, project folder, then replace with CMD, then type here code space, dots, then it will redirect into VS Code. Then I'm going to give explanation of the project. After that, I'm going to show how to exit the code. Make sure that all the files and folders are present in the intrusion detection folder. Intrusion input, this is one type of input video, and there is another set of input videos which are used to store images in the folder for this video and for this video. And this is the class name. But in this project, we are only going to use person. And then intrusion detection py, this is the final inference code. And then this is your requirements, txt file. We are going to install Ultralytics. This is the same image code for one video. And then the sort file, which is used to assign a unique ID to each person. And then the elevate model file. First, I'm going to give a code explanation of the project, and then I'll show how to execute the code. For that, we need to install the necessary libraries to implement the project. The packages are CV2, which is the OpenCV library used for image processing as well as image handling. Sort is a technique used to assign a unique ID to each person. Then NumPy is used for handling arrays of data. Then Tkinter is used to build the graphical user interface. Sys is a basic Python library used to perform some basic Python operations. Then import YOLO from Ultralytics, which is used to load the model as well as for model inference. CV zone is used to draw rectangles in an OpenCV window. Then import Tkinter. After that, import Tkinter. Fill the dialog TTK. Pillow is a Python library used for image processing as well as image handling. Thread is used to run multiprocessing. NumPy, date and time. First, we initialize the global variables. Initially, the program has not started, so running is set to false. Intrusion reduction is used to store unique persons in the intrusion reduction set, which uses the set data type. Initially, the video path is set to none. After that, the user should select the video path from this folder. Initially, the Polygon file path is empty. Once the user has made a selection, this path will be taken. After that, we need to load the Polygon coordinates, which specifically contain the set of the Polygon's coordinates as required. First, we need to read from the txt file, then evaluate the coordinates, and then store the coordinates in a NumPy array. Only then do we return. Otherwise, we do not return anything in the file information. If the file cannot be opened, then we need to display an error. Error reading Polygon coordinates. Then execution starts from this function, and the function name is intrusion detection. We have already initialized the global variable. Running intrusion detection is initially set to false, so the program is not running at first, meaning it is initially false. After that, we check whether the user has provided input or not. The input file names are video path and Polygon file path. If they are not provided, please select your video file as well as the Polygon coordinate txt file. The user must select a video for intrusion detection as well as a Polygon coordinate file. And this is the function that is used to load the Polygon coordinates. If the Polygon data is not present in the txt file, and loading the polygon coordinates fails, an error will be shown. Then this is the function that processes the videos one by one. Then load the YOLO weight model. This is a pre-trained model that can detect up to 80 pre-trained classes. But in this project, we will only use person detection and will not consider the other classes. Our main goal is to determine whether a person has entered the region or not. Next, this is a function that loads the YOLO weight model, performs inference using this model, loads class data containing 80 classes, defines your tracker, retrieves the original image's width and height, and obtains the polygon coordinate data. Initially, the intrusion detector is empty. If the person is centered within the region, the count in the intrusion detector is increased, which means the number of times intrusion detection has been performed for that person. Initially, the program runs continuously. If there is no frame, then execution stops. Read is used to process each frame one by one. The frames are stored in the frame variable and it returns either true or false. Then the image's width and height are stored as display width and display height. If the image width and height are too large, we won't be able to see the entire video frame. That is why we resize and store the values in the display width and height. Next, we resize the image's width and height to 800 and 450. Then we apply these values in this section of code, which reduces the original image width and height to the new image width and height. Initially, the stored detection is empty, meaning that 5 pieces of data will be stored in the variable. The variables are xzone, Ione, x2 and y2. These are the person's bounding box coordinates, and the confidence scores are also stored in this variable. And this is the model inference. We need to pass the frame into this function, and then the model will produce the output, the bounding box coordinates, the confidence score for the detected person, the class ID, and then retrieve your class names. If the detected object is specifically a person, then we only get the coordinates of the person's bounding box, convert them to integers, and store them as a new detection in a NumPy array. After that, we then convert it into a NumPy vertical stack in order to process the detections as follows. Next, we update the tracker, which assigns a unique ID to each person, and then draw the polygons using the already stored scaled region points in the variable. This sets the color and the line thickness is 2. Initially it is closed. Then this is for monitoring statuses. We need to specify some parameters: the font name, a font scale of 0.7, a font thickness of 2, and then the color. Next, process each result one by one after getting the tracking output. Then all the resources are converted to integers, and this function is used to correlate the center of the bounding box. With this formula, we can obtain the x and y coordinates of the person's bounding box, which forms a rectangle. but we are only going to use the midpoint xy. From this data, we can determine whether this point is inside the region or not. Then this if condition checks whether the midpoint of the box is inside the region or not. Then if the condition is met, the object ID is added to the intrusion detection set, which does not allow any duplicate object IDs. After that, the current time is obtained and updated in the Tkinter window. The window is named log intrusion. Once this condition is satisfied, we should display some information. The status intrusion detected is displayed using the CV2 put function along with the x and y coordinates of the intrusion. The font name is specified, the font scale is set to 0.7, the font thickness is 2, and the color is BGR red. Additionally, the bounding box around the person is also changed to red. Then the person ID is shown and the color is converted from BGR to RGB. This function is used to display the video frame in the Tkinter window. Finally, all the process frames are released. Log intrusion reduction is here. Tkinter opens another window which is used to display the object ID, the position of the person's bounding box, the XY axis, and the current date and time. This is shown in another Tkinter window. Start intrusion detection when the user needs to choose start intrusion detection, and then the global variable running is set. If running is true and the user stops, then the status changes and running becomes false. Then exit the Tkinter window, and then this is a function used to obtain a video file from the Tkinter window. The file format is MP4. Next, select the Polygon texture file. This function is used to obtain a txt file from the Tkinter window. First, we need to define the Tkinter object as root. From this object, we need to construct each Tkinter parameter one by one. The title is Intrusion Detection, and the Tkinter window size is 124 by 600, which is resizable. Then configure each setting one by one. This is a tab that demonstrates and displays the frame processing in a step-by-step manner, one by one. And then the live video is shown in the Tkinter window. This is for the log in another window, which is used to keep track of important events and messages generated by the system during operation. Then there's a label called Intrusion Detection, which will be shown above the processed frames window to clearly indicate the current monitoring mode to the user. This part of the code sets the background of the display area to black, ensuring good contrast, and then displays the video frame in the Tkinter window, making it easier for the user to observe any detected activity. All of these steps are essential for the proper functioning of the intrusion detector. Then this is the function that displays the object ID, position, date, and time in the intrusion log, which is another Tkinter window. Then this is a button. First, we need to choose a video file, and we also need to select a polygon coordinate txt file. Once the files are selected, we need to start the inference for intrusion detection. If you want to stop the execution, you need to click the stop button. The main loop essentially keeps running continuously in this process until we decide to stop it. I'm going to show how to execute the code. For that, we need to open terminal. First, I'm going to get images, which is just to draw polygon coordinate in an image using RoboFlow website. First, I'm going to install Ultralytics library. For that, we need to type here pip install our requirements txt. Then I'm going to enter. Ultralytics installing now. And now it is successfully installed, and right now I'm just going to execute save image, and now it is successfully installed. Then I'm going to run save image py, then file name, then enter. Now it is saving. Then I'm going to quit. Next, I'm going to show how to draw polygon coordinate in an image using RoboFlow website. For that, we need to go RoboFlow, polygon draw. Then choose this. After that, need to drop and drag here. I am now going to carefully select this very first image and then drop it right over here on the screen, just like this. Then I am going to create the intrusion line. Then I'm going to carefully select and obtain this particular point, and then after that I'm going to paste it right here in this specific place. Then delete this. It should be like this. Finally, I'm going to run the intrusion detection py. Copy this and the .py file, paste it here, then press enter. Now the Tkinter window has opened. The window is titled Intrusion Detection System Live Video Intrusion Log. Next, I'm going to select a video file. First, I'll choose intrusion input 1 as the first option. Select this, then choose the polygon coordinate file, point txt, and click open. Then start intrusion detection. Initially, the number of intrusions detected is 0. Once an intrusion is detected, the count increases. Now I'm going to start. Now at this very moment, the video processing operation is currently starting. The process is now officially underway, just beginning, and is in progress as we speak. Now an intrusion has been detected. A person crosses the line. When another person crosses the line, the intrusion detected count is updated to 2 at this very particular moment in time. Next, I'm going to provide another set of input video. So for that, what we need to do is bring the current process to a halt, and then after that, run the code again. Next, I'm going to select a video file, another set of input video, intrusion input 2. Please carefully select the polygon coordinate txt file, and then at this point I will now proceed to begin the inference process shortly. Now the person has entered the region and the intrusion detection count is 1. Next, I'm going to stop the execution. I hope you understood everything from my explanation of the project, how to execute the code, and how to obtain coordinate data using the RoboFlow website. If you have any questions regarding the project explanation or how to execute the code, share your thoughts in the comment section. Thank you.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely help you in as soon as possible in a better way. Thank you.